Alrighty, so we're going to be looking at Unit 3, Notes number 9. This is our last set of notes for Notes number 9, or for Unit 3, so get excited. Okay, so our goal today is I will be able to write the rule to represent a sequence. Oops. Let's see, right there. There you go. Alrighty, so we're going to be writing the rules to represent a sequence. Now remember, we can have rules that are, we have sequences that are arithmetic and geometric, but then we can have rules that are recursive and explicit. So we're going to be doing our recursive rules first, and then you'll see on the next page, we're going to be worrying about our explicit rules. Okay, so looking at our recursive rules first, just a brief reminder, for our arithmetic sequences, this is what our rule looks like. A sub 1 represents the first term. So that's where we put our first number. And then we have a sub n equals a sub n minus 1 plus our common difference. So this part of the rule never changes. Okay, it's just this and this right here that change. Okay, so whenever we write our sequences today, none of this changes. Or when we write our rules today, none of this is going to change. It's just these two numbers that we switch out. Same with geometric. Remember, g sub 1 represents our first term. And then the r is going to be our common ratio. So for all of our recursive rules today, none of this g sub n stuff is going to change. It's just the first term and the ratio that we switch out. Okay, so we're just finding those pieces, plugging them in, and then we're done. Alrighty, so looking at our examples, we're going to determine if it's arithmetic, what the first term is, the ratio or difference, and then fill in the blanks. So if we look at this first one, to go from 5 to 8, we add 3. 8 to 11, we add 3. And 11 to 14, we add 3. Since we are adding 3 each time, that's going to be arithmetic. Sweet. And then we have our first term. Since it's arithmetic, we know it's going to be a sub 1. Oops, that's a weird looking a, isn't it? A sub 1 equals, well, if I look at this, the very first term we have here is 5. And then we actually already found our common difference, and our common difference was plus 3. So we know it's arithmetic. We know it's the first term is 5, and our difference is adding 3. So now we just got to plug in our pieces. Well, we said a sub 1 was 5, and then we're adding 3. And that's it. Now, right now I gave you all this stuff, but we're going to start getting used to writing that as well. The next one. To go from 1 to 5, we add 4. But then we notice 5 to 25, adding 4 doesn't work anymore. So that means we have to look at what can we multiply by. So we can multiply 1 times 5 to get to 5. And then 5 times 5 gets me to 25. 25 times 5 gets me to 125. Since we're multiplying by something every time, that makes this geometric. So that means we're going to have g sub 1. Well, if we look at this, our very first term is 1. And then what was our ratio? We were multiplying by 5, so times 5. So now we just have to fill in the blanks. So we'll have g sub 1 equals 1, and then the 5 goes up front. And that's going to be it. All right, so notice that the next two are blank, so that means we're going to be filling in all of the pieces that go with them. So look at the first one. To go from 10 to 6, we're subtracting 4. 6 to 2, we're subtracting 4. And 2 to negative 2, we're subtracting 4. Since we are subtracting by the same thing every single time, that makes it arithmetic. Since it's arithmetic, that means we're going to use a sub 1. Okay, and our very first term was 10. And we already found what our difference was. We're subtracting 4. So this is our 2 key pieces of information. We're going to write out our sequence, and you can use this as a reference. So we're going to have a sub 1 equals our first term was 10. And then we had a sub n equals a sub n minus 1. And then our difference was minus 4. So minus 4. And then we're done. All right, last one. So to go from 81 to 27, we're subtracting a lot, but then we'll notice that that's not going to work for the rest of them. So that means we have to look at what can we multiply by. Since our numbers are getting smaller, that means we're multiplying by a fraction. So to go from 81 to 27, we're actually multiplying by 1/3. 27 and 9, we're multiplying by 1/3. And 9 to 3, we're multiplying by 1/3. Since we are multiplying by the same thing every single time, that's geometric. Since it's geometric, that means we need g sub 1. And our very first term is 81. And what was our ratio? We were multiplying 1/3. So now we're just going to fill in all of our pieces. We're going to have g sub 1 equals, my first term was 81. And then the rest of our rule looks like this. So we'll have g sub n equals, our ratio goes up front, so 1/3. And then g sub n minus 1. And that's it. Alrighty. Quite a few examples. We're doing great though. Alright. Looking at example number 2. We have determine if the following sequence is arithmetic or geometric, then write the recursive rule for the sequence. So this right here, guys, is what your test question is going to look like. I'm not going to give you a table to fill in. It's going to be a question like this. So first it asks if the sequence is arithmetic or geometric. Always read the directions, because notice that there's that first question there. Okay, and then it says now write the rule. But first we have to identify if it's arithmetic or geometric. Guys, you're going to get a point on this type of problem just for telling me that step. Okay, and it's only a 3-point problem. So even if you can't remember anything, if you can at least tell me this, get you a point. All right, so to go from -6 to -3, we're adding 3. -3 to 0, we're adding 3. And 0 to 3, we're adding 3. Since we're adding each time, this is arithmetic. So that means we need to start with a sub 1 equals, our very first term was -6. And then we'll have a sub n equals a sub n minus 1. And then what was our difference? Adding 3, so plus 3. And then we're done. All right, we're going to go ahead and skip to the back. This one is just like what we did up here, okay? So skipping to the back. Now we're going to be looking at our explicit rules. So remember, explicit rules define a sequence as a formula in terms of n. And if we look at this, it is just like our recursive where the rule stays the same. We just fill in our extra little pieces. So if we look at the first one, a sub 1 always goes up front, and that's always going to be the first term. And then our difference goes in front of the parentheses. So the rule stays the same, it's just these two numbers that will change. Same for geometric. G sub 1 is our first term and it always goes up front. And then the R is our ratio. So those two numbers are the only numbers that are going to change. Everything else stays the same every single time. All right, so let's look at our table. Notice I've given you the blanks to fill in, and then on the next one we'll write the rules. So from 5 to 8, we're adding 3. 8 to 11, we're adding 3. And 11 to 14, we're adding 3. So since we're adding 3 each time, that's going to be arithmetic. And then we need our first term. So it's arithmetic. So we're going to do a sub 1 equals 5. And then we actually already found our common difference, and that's going to be plus 3. So then looking at our rule, we just need to fill in the blank. A sub 1 always goes up front, so 5. And then how are we changing? We're adding 3. Not so bad. Looking at the next one. From 1 to 5, we're adding 4. But from 5 to 25, adding 4 doesn't work anymore. So that means we have to use a different rule. So what can we multiply by? Well, from 1 to 5, we're going to multiply by 5. 5 to 25, we're multiplying by 5. And 25 times 5 gives me 125. So since we're multiplying, that's going to make it geometric. And we need our first term first. So it's g sub 1. Our first term was 1. And then if we look at this, what was our ratio? We were multiplying by 5. So now all we have to do is fill in the blanks. Guys, this box was supposed to be a dot. There we go. So it's going to be g sub 1 equals 1 times 5 to the n minus 1. This right here is an exponent, okay? Don't write it big. It's supposed to be an exponent. Alrighty. So let's try a few without the rules where you have to write the whole thing. So looking at this, we have 10, 6, 2, and negative 4, or negative 2. So from 10 to 6, we're subtracting 4. 6 to 2, we're subtracting 4. And 2 to negative 2, we're subtracting 4. We're subtracting by something each time, so that means this is going to be arithmetic. So then we also need to write our first term. Well, the very first term of the sequence is 10. So that means a sub 1 equals 10. And we already found what our difference was. We were subtracting 4. So we're going to be subtracting 4. So now we just need to write our rule and fill in the blanks. So a sub n equals, our first term was 10. And then our difference was minus 4. So minus 4 times n minus 1. That's it. Same thing with the next one, letter H. I don't know if you noticed, guys, but these are all the same ones that we did on the first page. I must have copied the table and forgot to change them. It happens. So from 81 to 27, if you look on the first page, we're multiplying by 1/3. 27 and 9, we're multiplying by 1/3, and so on and so forth. So since we're multiplying, that makes this geometric. Our first term was g sub 1, which was 81. And then our ratio was 1/3. So we're just going to take all those and fill in the blanks on our rule. So it starts with g sub n equals our first term, which was 81, times our ratio, which was 1/3, and then to the n minus 1 power. I always put the 1/3 in parentheses when it's a fraction, just so it's a little bit easier to use. Alrighty. If you have any questions on those, please make sure you're asking. Hit pause if you feel like I'm going a little too fast. Okay. We just got a few more examples. We're almost done here, guys. So look at example number 2. It says, determine if the following sequence is arithmetic or geometric. Remember, you get a point just for telling me that. And then write the explicit rule for the sequence. So, to go from 8 to 3, we're subtracting 5. 3 to negative 2, we're subtracting 5. And negative 2 to negative 7, we're subtracting 5. So from here, We know that we're subtracting each time, so that's going to be arithmetic. And now we just need to write our rule. So a sub n equals, we start with our first term, which was 8. And then our difference was subtracting 5. So minus 5, and then n minus 1. Only the two numbers change, everything else stays the same. Okay, last one. It says determine if the following sequence is arithmetic or geometric, and then write the explicit rule for the sequence. So, looking at this from 48 to 24, we're getting smaller. Okay, so we can start with subtracting 24, but then from 24 to 12, that doesn't work anymore. So we know we need a different rule. So it's getting smaller, so that means we need to be multiplying by a fraction. Well, to get to 24, that's half of 48. So we're going to multiply by 1/2. 24 to 12, we're going to multiply by 1/2. And 12 to 6, we're going to multiply by 1/2. So now we know we're multiplying, so this is geometric. Remember, you get a point just for telling me if it's geometric or not. And now we can write a rule. So we have g sub n equals our first term, which is 48, times our ratio is 1/2, so in parentheses 1/2 to the n minus 1. Remember, this is an exponent, so write that as an exponent. Alrighty, that's going to be it. Guys, congrats. We finished our last set of notes for Unit 3. Make sure you're asking questions if you have any of them, and then you can move on to your homework assignment.